I thought I'd make a video of this question just to explain, but this is something I'll put up, and this is the way I would explain and how I would handle a problem like this. So let's say we have a cart that's moving to the right with constant speed of 20 meters per second. Now, one of the things we learned in kinematics, what does constant speed tell us, is that the acceleration is zero. Because there's no change in the velocity. Now, technically, when we do circular motion later on, this is not exactly going to be true. You have to be careful that if it's moving in a circle, then it's not a is zero. But like for the most part in kinematics, if it's moving in a straight line, the speed's not changing. There's no acceleration, right? Acceleration is the change in velocity per time. So box of mass, 80 kilogram, moves with the cart without slipping. Without slipping means that they're going to move together in tandem. That's what it means, that they're both moving at 20 meters per second together. They give you a coefficient of static friction and the coefficient of kinetic friction between the box and the cart. Okay? What are the magnitude and direction of the frictional force acting on the box as it moves with the cart? So step one, with force problems, we always draw a free body diagram. We want the one acting on the box, so let's draw a free body diagram of the box, all right? So what are the rules? Remember, there's a separate lesson. I would go back and look at how to draw free body diagrams, okay? That's like a key lesson, but there's gravity acting downward towards the center of the earth. That's always the first one we put. And you can write it as mg, but you know the mass is 80, so 80g. Then you examine what is touching it, right? So the cart is touching it right here. It exerts a normal force up here, perpendicular to the surface, because this is a surface, and surfaces can only push. This part is not like glue or sticky where it's stuck to it or anything. It's pushing upward. All it can do is push. It cannot pull, all right? And it has to be perpendicular to the surface, okay? Is there anything else touching it? No. Now, with friction's always a tricky force. So I didn't give you guys rules on friction yet, or I don't think I have a separate lesson on this quite yet on my YouTube channel. Frictional force, you have to first identify, is it static or is it kinetic? Okay. Static is when they're not rubbing against each other, or more formally, if they're moving with the same speed, they're not moving relative to each other. It's static friction. Okay. Kinetic friction occurs when the two surfaces are rubbing against each other. And that means one is sliding relative to the other one. This is kinetic friction. This here, when my hands are stuck together, static friction. I hold a calculator here. If I'm pushing on it and it's not moving relative to my hand, static friction. Once it starts sliding relative to my hand, kinetic friction. Okay, that's the difference. Now, static friction, so this is definitely static friction. Now, how do we know the direction of static friction? There's two tricks that I use for static friction. One, I imagine if there were no static friction, what would happen? That's sometimes pretty hard. Like, if there were no friction, what would happen to the box? That's sometimes a little bit hard for some people to use. So another trick is to see, like, what is the acceleration of the system? So the A is 0. That means there's no net force in the horizontal direction. So let's suppose I said the frictional force was to the right. There are no other forces acting on the box because nothing else is touching the box. So that means that there would be a net force to the right, so it would have to accelerate to the right. What if the frictional force was to the left? Well, that would mean there has to be an acceleration to the left because there's no other forces. There would be a net horizontal force. There's only one force in the x direction, the frictional force. The acceleration would then be going this way, right? Because F net equals ma. So what's the reality is, because the acceleration is 0, there is no frictional force. It's 0. Because there's no acceleration happening in the x direction. So the net force is 0, and the only force that could be horizontal is the frictional force, because nothing else is touching it.